Hello and welcome to this tutorial on how to represent text on a computer, and in particular the coding scheme we're going to be using is the Ascii. And so what we're going to learn is how text essentially boils down to ones and noughts on a computer, and also how we can detect errors within this format. You'll probably already need to know a little bit about binary numbers and also a little bit about hexadecimal. So first things first, it's probably important to point out and make sure that you're aware that everything needs to go down to ones and zeros on a computer. And that's because the storage mediums for data and the transmission mediums work in a kind of discrete on-off, true, false kind of environment. So for example, a hard drive will either have a magnetic charge at a position or not have a magnetic charge at a position. Equally, CDs have dips in their surface representing ones and flat areas representing zeros. And finally, if you're transmitting data down a wire, their being voltage there might represent that there's a zero, and their not being voltage might represent a one. And so when you look at a piece of text that's been encoded, or in this case a single character, the first thing that has to happen is that you give that character a number, and you'll see here that we've got the number 65 because capital A is the 65th letter, and then that 65 needs to be converted down into binary, and you can see here that I've given it a hex value, as in 4 and 1, because that's 4 lots of 16 and 1 plus 1. And then finally I've given it the binary base 2 value. So every piece of text that you see stored inside a text document will be converted into a number and then in turn converted into binary before it's stored on the actual hard drive. So if we look at that in a little bit more detail, this is the Ascii code chart. Now Ascii was a standard invented quite a while ago, and it was the first real attempt at getting some kind of consensus on what the ones and noughts sequences would be for the alphabet. And you'll notice that it's got 32 non-printable characters. So these are things like backspace, delete, there's null value, and escape. And these are the kind of the commands that you have on your keyboard that will do things to the text. And then once you've got past those, you can see that there's the printable characters, and they include uppercase letters and lowercase letters. It's also important to note that the order of these, so for example, uppercase A comes before lowercase a, and so actually uppercase Z will be before the alphabet than lowercase a, and so instead of it quite being in alphabetical order, this is said to be in ASCII-betical order, and therefore if you were to compare the value Z to A, little a would say that big Z was a smaller value than little a, and that might be kind of counterintuitive. You also note that there are some symbols between the two alphabets as well, and so you can't necessarily judge all the symbols to come first and then all the numbers, because they're kind of broken up throughout the text. And the way in which it's ordered is starting from 0 at null, as in 0, 0, 0, 0, 0, 0, 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The ABC is hexadecimal going up to 15. And then as we go on to the second row, it's 16, 17, 18, 19. And I'll take a single example of this. So if we look at the character D, then we can see that that's the value of D is in hexadecimal 44. And I'll just convert that into binary for you. So if we've got the number 44, we know that there's a quick way of converting this into binary, and that's to take the first 4 and represent that as a binary number, and the second 4 to represent that as a binary number. Equally, we could convert it into denary by saying that because it's hexadecimal, the first row is lots of 1 and the second lots is lots of 16, and so that's 4 times 16, which is 64, plus 4 times 1, so 4 times what, which is 4, which equals 68. And if we look over here, we know that that's 64, that's 16, 32, 16, 8, and 4, equaling 68. And so what you can see is each one of these goes 1, 2, 3, 4, 5, and the Ascii represent and the hexadecimal numbers represent it. And that's actually helpful when you look at the bit code, because it makes the things to start, it makes the values seem to start to have a little bit more sense. And so if you look at in this encoding, you can see that anything starting with a 00 is an unprintable character, and equally, apart from the delete, of course, which is right at the end, which is all the ones, and also the positioning of the A characters, for example, and the starts of alphabets correlate to their bit codes, and the bit order would be starting with the first one here, working up to 4, 5, 6, and 7. And you'll also notice that there's only 7 bits in Ascii, meaning that it can represent 128 different characters. And the reason for that is because it allows a parity bit to be placed on within it, and that's to check for errors. And I'll demonstrate that now. So if you had Ascii and you're working with a system of even parity, so you have an Ascii value 1, 1, 1. You've got your 7 bits of Ascii, and the final one you leave as kind of a check digit. And you say that once this is transmitted, there should be an even number of ones in total. So you place that as a 1, and therefore there's even. And when it gets transmitted, if it comes back as this, with the check digit, you will know that because there's now an odd number of ones, it means that there's been an error, and this is incorrect. And so use of even parity is there as a kind of very rudimentary mechanism for ensuring that there's been no errors during the transmission of a signal. I'll give you another example. So we have the number 1, 1, 1, 1, 0, 0, 0. There is an even number already, and therefore the check digit or the parity digit should be 0. So there's an even number to start with, and you can check against this once you receive the message. And so to summate, what have we done? We've looked at how characters are represented using the Ascii alphabet on a computer. We've talked about the importance of international standards, and Ascii really represented the first attempt at getting an international standard for an alphabet so that all computers could work with one another easily. We talked about the being aware of Ascii-betical order, knowing that some things aren't necessarily in the order that you'd expect them to be in. And finally, we've talked about printable and non-printable characters.